in this module, we're going to move on to the second symmetry operation, reflections. So let's talk about those. So here, again, we have pure reflections. This is also known as a mirror. So when I mentioned the symmetry in the human body, right, it's this one. This is a mirror plane. So it's characterized by a plane. So this is also known as a mirror plane. And we sometimes represent this as a thick line. So for us, I'm going to have the plane basically go across. So my mirror plane is coming up where you can see my hand here. So that's the mirror plane. So different than the rotational axis that we saw in the last section. So basically it's represented by a thick line in these drawings. You could also see, sometimes you might see it represented by this, and that would indicate that the actual plane, the mirror plane, is the paper itself, right? So we can have different variations here, but we have to define a plane in terms of these reflections, right? So in the human body, right, so if I just draw my stick figure here, that represents my person, then the mirror plane is basically splitting the left and right. So that's right here, right? So my mirror plane is going straight through them. That's my mirror plane, right? Just as reference. So we can also represent it in our sort of circle drawings that we have as this. So this line through is my mirror plane, or again, if it's the plane of the paper, you might just draw that circle extra thick, right? So that's the plane of the paper. So basically the same ways of drawing the same thing. Different ways of drawing the same thing. All right, so let's look at how we do this. All right, so if I have an object on this side of the plane and it's above the piece of paper, so again, that's what the plus is. It's above the axis. Then on the other side, I'm also going to have that, and it's going to be above as well. So same thing, if I draw a point down here, it's reflected across that mirror plane and it's going to show up right there. Now in this case, if I have an object that's above the plane, since the plane is actually my paper, if I'm saying, again, my object is above, up here, it's on the positive side, so it's above the plane, then when I reflect it, relative to my piece of paper, it's actually going to be underneath the table, right? I can't really show you that, but it's going to be underneath that plane, right? And so the plus then turns into a minus. So basically, it's in the same position, but I have one above and one below the piece of paper is what I'm showing there. So the way we would sometimes draw it as having our object and then having an open circle in the same place to indicate that it's below. So you might see it plus minus, or you might see it represented like this. Also, another thing that might come up every once in a while, I didn't put it here, but sometimes you might see a comma in these two places, indicating this. This refers, the comma here, right. This refers to what we call the handedness. So the comma here refers to the handedness. And so a way of thinking about that is to draw a spiral. If I reflect a spiral across a mirror plane, it goes the opposite. The spiral goes the opposite direction, right? So the rotation goes in an opposite direction. So the spiral spirals the opposite direction. So I'm not going to really expand on this too much, but if you get more into crystal symmetry, this might come up, and it's just referred to as handedness, and it's the idea that if I take something that rotates like a spiral and reflect it along the mirror plane, the rotation changes, the handedness changes in those cases. So again, it won't really come up much in our lectures today, but just in the future, if it ever comes up, the idea of handedness, or if you see this comma and you're wondering where that comes from, that's what it's referring to. All right, now I want to move on to the third symmetry operation, which is operator or element, which is inversions. All right, so let's talk about inversions. So an inversion is what we call a point symmetry operation. So, we've been talking about points, arbitrary points in space and how they rotate. So that's what we're referring to. So this is a point symmetry operation that takes all the points represented by a vector, and we call that vector R. So R with the arrow on top of it. So it takes everything represented by that vector of an object and projects them into new points represented by a vector minus R. Right? So this one's easy to think about if you actually think about the vector itself. So again, you can think of, with this, we obviously, like we talked about last time in the last lectures, we had points and directions, and we always had an origin, right? So we can think about that point in space with relation to its origin, and the vector between those two is R. So basically what happens is we take that point such that we form a new vector, negative R. So basically all of the x, y, z points become negatives. And so what that's going to look like is if I have an origin here in the center, right, of my space, and I have an object represented here. So this is the origin. So I've represented it as an open circle, and I have an object. It's above the plane of the paper, right? So now if I invert that point, it's like saying I'm taking this vector R and making a negative vector. And so there's going to be a negative R over here where all the x, y, z positions are opposite. And so my point is going to be over here, but it's going to be negative, right? This one's above, so it's going to get inverted below the plane. And it also has that change in handedness, which again, we don't deal too much with, but it's inverted. So basically, you have to define an origin. So that's this point here. You look at the vector R, and then all the points are made negative. So all the x position, all the y positions, and we take it over here. So we can also draw it in these circle drawings that I've been doing with a point. This is my object. It's inverted through this origin, so that's going to put it over here, and I represent it as an open circle because it's below. So closed circle means positive, open circle means negatives, if you're thinking about it in these directions. And the reason I'm drawing it different ways is because depending on the sources you're looking at, you might see it drawn different ways to represent these symmetry operations. And so this origin we also call the inversion center. So this is that open circle. So if you see the open circle, that's referring to an inversion center.